Good morning everyone. Let us start understanding. This is understanding class, no JEE IIT class. First you understand the concept of differentiability. This is the chapter where you need to use your concept, you need to use your sense of calculating limit. So differentiability of a function, its origin is there in class 11 differentiation only. That when you do first principle of differentiation, then you can see that f dashed a, I mean the value of dy by dx at x equal to a, what is the value? Limit h tending to 0 f of a plus h minus fa by h, isn't it? This is differentiability of a function. I mean differentiation of a function. So derivative, or you can write this one as f dashed a also. F dashed a. F dashed a means dy by dx at x equal to a. So at x equal to a, derivative exists if the limit on the right hand side exists. Am I correct? So you are writing for differentiability at a point x equal to a, limit h tending to 0 f of a plus h minus fa by h must exist. That is, the condition going to be limit h tending to 0 minus fa by h tending to 0 plus fa by h must exist. This is clear, understood? But you may not like writing this manner. So I have an alternative for you that I am going to show you. The same thing can be written as limit h tending to 0 f of a minus h. Some of you might be habituated this manner or started doing continuous differentiability, already you are practicing it. So I am telling you, both are possible. You are not wrong if you use this one or this one. F of a plus h minus fa by h. This is also possible. Clear? So this you have to keep in your mind for differentiability at x equal to a. We need to check this one or by this method, whichever convenient for you. Okay? Before we go for graphical presentation, definitely graphical presentation is there and it is very interesting to solve graphically differentiability problem for entrance examinations. But I told you this is understanding class. Understanding class means it will be for your board examination. Okay? Do not neglect the concept of a chapter. If concept is strong, then you can do any sum. If you know ABCD, you can read a novel easily, isn't it? Let us proceed. Let us try to understand with one example whether it will be differentiable or not. So let us start with the function fx equal to mod x. Okay? This function is continuous. We have seen that. Is it differentiable? Say at x equal to 0, we are checking. Check differentiability of this function at x equal to 0. Okay? I told you your strategy is to write the function properly, that fx equal to x for x greater than 0, 0 for x equal to 0, minus x for x less than 0. Isn't it? So now after this step, when you are answering it for a descriptive paper, this is the only difference. Here you learn concept. That concept will help you to solve everything. But you need to write some lines, what you are going to do. Maybe mathematical form or literally, whatever you like, do. So you will follow the steps I showed you already, that we have f dash 0 equal to what? Limit h tending to 0 f of h minus f0 by h. Why? Because f dash x, you try to remember the definition. It was f dash a, sorry. It was limit h tending to 0 f of a plus h minus fa by h, no? You have taken a equal to 0 here. So this is the limit. If this limit exists, then it is differentiable. Find left hand limit. LHL. Limit h tending to 0 minus. Am I correct? H tending to 0 minus. It is something like x less than 0 minus x. So you will be taking that part. Or okay. If you don't like to write it, you just change. Which part you need to change? That I told you earlier. That h part. That h part, you write f of minus h minus f0 by minus h. Do proceed. So you write this as minus h minus h. Perfectly alright. This will be limit h tending to 0 f of minus h. Where will you get? At this part, fx is minus x here. Put by minus h. So this value is going to be 1. Check once. No, it will be minus plus, no? Because we are finding f of minus h. So this is minus 1. Yeah, now it is correct. This thing is minus 1. Because minus of minus h. And now we have to find RHL. RHL will be limit fh f0 by h. So simple. We'll be taking h, f0 is 0. Clear? So answer is 1. The function is not differentiable at, therefore fx equal to mod x is not differentiable at x equal to 1. At x equal to 0, sorry. Why x equal to 1 coming in our mind, you know? The only sum given in your textbook. Check continuity. That's why I did not take that sum. Check continuity of fx equal to mod x minus 1 at x equal to 1. This is your homework. You must try, or before the next class you write what kind of problem you are facing here. Okay, today I'll show you just elementary concept of this calculation of differentiability, whether a function differentiable at a point or not. Clear? Now let us take a very interesting function, that fx equal to, I am writing x square sine 1 by x, x not equal to 0. Why I am taking this? In continuity past session I have taken both the functions. So that's why I am discussing their continuity and differentiability part both. X square sine 1 by x we have done in continuity first session. So let us see what happens there. For this function fx equal to x square sine 1 by x, for x not equal to 0, equal to 0 for x equal to 0, you are going to check differentiability at x equal to 0. So again you write the same thing. This thing will not change. F dash 0 is, I have explained in the previous sum, fh minus f0 by h. So let us write LHD, or you can write L f dash 0. This is limit h tending to 0. I think board is very clear. Okay, h tending to 0, f of minus h, f0 value you just put it there, by h minus h. Clear? This approach you understand? Now let us put the value of f of minus h over there. This is going to be limit h tending to 0, fx is this. One thing make it clear, if you put minus, okay, let us put it without hesitation. You just put minus h whole square sine of minus 1 by h by minus h. Okay, so this thing going to be limit h tending to 0, h square minus sine 1 by h by minus h. This to get cancelled. So this is now reduced to ordinary limit problem. How do I evaluate this limit? 0 into a finite quantity between minus 1 and plus 1. What will be its value? This thing going to be equal to 0. So L f dash 0 equal to 0. For this function, L f dash 0 equal to 0. A function, a finite quantity between minus 1 and plus 1, 0 into that must be equal to 0. Now let us check it with the RH derivative. Doing it here only, RH derivative. RH derivative I am calculating side by side, that RHD, which is R f dashed 0. This is nothing but FH f0 by h. Clear? So what should I put? Plus h only. Here we replace by plus h. So this will be limit h tending to 0 h square h 1 get cancelled. So this will be 0 into the same manner you will be writing your answer 0 into a finite quantity between -1 and +1. So the value is equal to 0. Clear? So what have we got here? Both the limits exist and they are equal to 0. So your answer will be the function is differentiable at x equal to 0. Clear? Understood? Now let us take another kind of sum. Okay, this I give you one homework, just corresponding homework, so that decision making will be easier for us in the next session. Okay, I'm just writing the sum. That take the function, this is your homework. You must try, you all must try. Otherwise I'll be discussing on your demand only that we do not understand. Just write the sum in details. Function fx equal to x to the power m. This is a very important sum for board as well as for your all entrance examinations, including CBSE, JEE, whatever you say. This function given like this. Question is, show that the function is number 1 differentiable for m greater than 1 but not differentiable for m less than equal to 1, and you will remember the result for future. Clear? You try, not now, you try at home, and before Tuesday session you must ask me. Okay, you can send me WhatsApp, you can write in the description of this live session. It will exist in YouTube, so you can write there also. Clear? Let us do derivative of this kind of problem. Just let me write a sum here, that fx equal to just two parts of function given. I am taking that kind of problem. Okay, different types we can discuss. I will be discussing all the types, all common types of differentiability problem. Let us take fx equal to 12x minus 13. I am taking it from R.D. Sharma. R.D. Sharma, exercise 9.1, sum number 2 here. In R.D. Sharma it is problem number 2. Okay, 12x minus 13, x less than equal to 3. 2x square plus 5. Today no graphical idea, just analytically how to find, show that it is differentiable at x equal to 3. Also find f dash 3. We have to answer this question. 12x minus 13 for x less than equal to 3, 2x square plus 5 for x greater than 3. Show that it is differentiable at x equal to 3. Also find f dash 3. How to proceed? So LHRs you will find definitely. Before that, you write this thing clearly. F dash 3 they asked. So it is limit h tending to 0 LHD or ALF dash 3, you just replace H by minus H. So this is limit H tending to 0. 3 minus H is this part. You put F3, you have to put there only. Okay? (12x minus 13). Expected to be, acha, this is minus H. This is minus H. Isn't it? 12 into 3 minus H minus 12 into, just a minute. Yeah, I forgot to take minus 13. Yeah, thank you. So this will be limit H tending to 0 minus 36 plus 13, this by so the answer going to be 12 H by H. H not equal to 0. So the value is 12. So you got ALF dash 3 equal to 12. Let us find RF dash 3 on this function only. I got, because 36 minus 30, this they are getting cancelled. Clear? Let us write the value of right hand limit. Side by side I am calculating for right hand limit also. RH derivative or RF dash 3. RF dash 3 will be limit, just don't change the sign here, you will keep the same manner. F of 3 plus H minus F3 by H. F of 3 plus H is this part. F3 will be that part only, 12 into 3 minus 13. This divided by H. 2 into 9, 6H plus H square. Okay? This minus, plus 5 minus 23 by H. 18 plus 5 and minus 23 get cancelled. It is going to be limit H tending to 0, take H as common, 12 plus 2H by H. Clear? H not equal to 0. So this is going to be 12 plus 2 into 0, value is 12. So what is your observation? That is 12, this is also 12. Clear? Understood? So this function, the given function is differentiable at x equal to 3. Clear? Understand? Let us do another one where you need to find the values of a and b. I am taking this sum from R.D. Sharma only. It's okay? This one 2 into 9 plus 5 and here 36 minus 13, 23. Clear? Now let us take this one also from RDS number 7. I am going to do exercise 9.1. So in our class it is some number 4. Find A and B so that fx equal to 3x plus a bx plus 2 x greater than 1 is differentiable at, I am showing you just elementary examples today, but suddenly this question arises. Have I told the concept? Differentiable at each x belongs to R. Unlike continuity, actually there is no difference. If differentiable over the whole interval at every point, then it is differentiable for x belongs to R. On the number line, it is differentiable everywhere. This much concept you just accept today. So it will be differentiable at 1, it will be differentiable at 2, it will be differentiable at 0, minus 1, minus 2, whatever you say. Isn't it? We don't need all these things. This function differentiable at each x belongs to R, it will not provide any extra information if you don't consider differentiability at 1. At 1 is enough. We just consider differentiability at x equal to 1. Then everything is done. Okay? So you can put a statement over there. If you are going to answer for board paper, you will write as fx is differentiable for all x belongs to R, therefore it is differentiable at x equal to 1 also. Okay? So let us use that concept here. It has to be differentiable. We can use this information. They have given it is differentiable. Find A and B. So we can assume all the conditions here what we have done before. That left hand derivative equal to right hand derivative. This implies what? This thing will imply that A left dash 1 equal to R f dash 1. What is f dash 1? We have to write f of 1 plus h, f1 by h. So now we'll be finding, we'll be comparing these two things. So A f dash 1 equal to R f dash 1. This implies that h tending to 0, f of 1 minus h. Am I correct? Limit h tending to 0, clear? So just put the values and see the problem over there. See the difficulty level is there. Then I'll put my hand for this. You just put the values over there. Just substitute. Whatever you have, just substitute. So this is what? F of 1 minus h is this part. 1 minus h whole square. 3 1 minus h. F1 will be taking that part only. By minus h. F of 1 plus h, you have to take this part. F1 that part only. Is that clear? Just simplify it in the next step. See what you are getting there. This implies isn't it? Now here 1 plus 3 get cancelled, a also get cancelled. So it will be limit h tending to 0, h square minus 5h by minus h equal to limit h tending to 0. This part has become a bit complicated. bh plus but they said that it is differentiable at x equal to 1. So far we have reached till this step. What next? Left hand side there is no problem. You see it is coming to be h minus 5. These two are getting cancelled nicely, but problem is there. First part no issue. bh by h if you separate, b plus, here I got stuck. If I put h equal to 0, it is going to be undefined. But they said that it is differentiable. So what to do? We have to put this part equal to 0. Which part? This part. So you write your comment here for differentiability. For differentiability, the limit on RHS must exist. That is, b minus a minus 2 must be equal to 0. Then only it is obeyed. Therefore, b equal to a plus 2. This one added condition. And here you got something. By putting this part 0, it's coming. So b you are getting from here. It is minus 5. By putting b equal to minus 5, you can get a from there. If I am not wrong, I showed you the method. I hope you have understood. This implies a going to be b minus 2. Which one? Minus 5. So if you put h equal to this to get, this will be plus 5, sorry. This will be plus 5. So a going to be 5 minus 2, this is going to be equal to 3. Hope you have understood. Okay? Differentiability, many things are there. Very interesting topic, but you have to wait till Tuesday. I expect solution of elementary sums from this will get in addition, and from my worksheet many sums are there. These elementary sums you complete before Tuesday's session. We'll have one session on continuity, another one again on differentiability, so that you understand, and this series will continue. Okay, so long all JEE problems also not over. Thank you for staying with